Okay, next up we have one of our sponsors, Precision, who are our silver sponsor, and Anthony Clarkson is going to give us a quick presentation intro to 400 gig ZR optics. Anthony.
Cool, thanks Jen. And good afternoon everyone. So I'm going to give you a very brief overview of some of the 400 gig ZR pluggable optics. I'm going to apologise in advance that although I'm British and I'm going to try and say ZR every time, I've worked with a lot of Americans that call it ZR. So if I say ZR, my apologies. So the first thing to say really is there isn't just one 400 gig ZR pluggable optic. There are a variety of different options. And to kind of give you an idea of a flavour of some of the things that are out there, there's the OAF have standardised a 400 gig ZR optic that is pretty much a 400 gig optic. It does 400 gig and not a lot else. The Open ZR Plus consortium came together and said, actually, maybe there's other use cases. Maybe we want to do 3 by 100 gig or just 100 gig or 2 by 100 gig or 4 by 100 gig in breakout mode over the same sort of distances. So they added to their standard the ZR Plus, if you like. So the key difference between ZR and ZR Plus is 400 gig only versus multiple different options. I'll go into some of that in a later slide. There are some other differences as well. And then you've got CMIS, which is the common or configuration management interface specification. And that's how all 400 gig optics talk to their host device. So if you're plugging it into pick a vendor at random, Juniper, because Neil's sat in the front row. That's how the Juniper talks to and configures the optic over that interface. So it's a way of sending configuration data to a pluggable optic from a host. Then there's a variety of different transmit powers on these devices. So the initial batch of optics that came out were kind of neg 10 transmit power, which is fine for certain use cases, but if you've got existing ROADM networks where you've got to hit a specific transmit window, you need a bit more flexibility in the transmit power. So there is 0 dB, which they call high transmit, and we've got plus 4 dBs, and there's going to be higher transmit power optics available as the technology improves. Obviously, it comes at a cost. The more amplification you put into the optic, the more electrical power it draws, so you need to be able to deal with that. And the kind of use cases for these depend on whether you want to use them unamplified, in an amplified system, what sort of range you're looking at. Basic configuration, you can get 2 ZR optics, plug them back to back together over a 40, 50, 60 kilometer link with some of the ZR Plus, 0 dB transmit, amplify networks. You can be looking at 2,000 kilometers maximum. So depending on what your topology is, it's going to depend on what you need to buy. You need support in the host platform. These are not going to work in the majority of 400 gig switches that are already been deployed. There's licensing requirements, there's power requirements, configuration requirements. There's options for form factors. Obviously, most people are going to want QSFP-DD. It seems to be the de facto standard, but OSFP is available. Even good old CFP2s are available for this sort of technology. And then there's other things as well that are kind of ancillary. 100 gig ZR is something a lot of people are talking about. QSFP28 that can do the 100 gig version of what a 400 gig coherent optic can do. And there are some interesting grey optics out there as well. So some of the challenges and the things that are out there is there are a number of different host vendors that accept these. The Ciscos, the Junipers, the Nokias, and others, white boxes as well, that are pushing support for this technology. And they all interact with the optics in a very slightly different way, depending on which optics they've qualified, essentially, to start with. And then you've got a number of optic manufacturers, the guys that are actually making these pluggables, the guys like Coherent, Lumentum, Acacia, for example. And then you've also got the chipsets that are on these, the DSPs. So Marvell, Broadcom, Acacia, Sienna, to name a few. And then you've got challenges around OLS vendors. So there's a lot of different configurations of hardware out there and software. So what does that mean? Oh, what else is there? So some of the other things, we kind of touched on it earlier, there's the different line rates. So you can run these at 1 by 400, but you might want to run 4 by 100 in order to break out. In some cases, you might run 3 by 100 or 2 by 100. And for different reasons that you do that, one, you might not need the capacity, but also you can get extra reach. Because if you're running in a different modulation rate, to do 1 by 100 or 2 by 100, you can improve your OSNR, which means you can amplify it further and go longer distances. So it's not, although it's 400 gig ZR, it's not just about 400 gig. So yeah, different modulation types, whether you're doing 16 QAM to get 400 gig down a single fiber, well, it's all down a single fiber, but fiber pair, or something like QPSK just to get better OSNR. And then there's different FEC modes as well. So OFEC and CFEC are the two main types of forward error correction that are supported by the different standards. There are some proprietary ones as well, and it's all about getting for the distances and increasing the OSNR. OSNR is king in this. So what about interoperability? So we've got lots of different hosts, lots of different software versions. We've got, so that's one challenge, is how do the optics work in the different host systems? You've got A-end to B-end interoperability. If I've got a Cisco box at this end and a Juniper box at this end, and I buy the Cisco optic for the Cisco box, and the Juniper optic for the Juniper box, and they've got different DSPs on them, they've come from different manufacturers, how to get them to work? And there will be some base configuration that is supported by both. So there's a challenge in understanding all these different configuration options to make sure you can get build something that works. And it could be the FEC, it could be the modes, your optical line system. The good news is the OIF have been running plug fests for the last 2 years at OFC and ECOC, where a variety of vendors of host equipment, optics, line systems are getting together, plugging things together, and saying what works and what doesn't work. The challenge is whether the software that they use at the Plugfest is the same software that will sell you guys. So, a couple of application scenarios. Well, why do you need this? Well, I've already got a transport network. Why would I want to buy this? Well, you can use this as alien waves on an existing system, get to remote locations, should be cheaper to build. You're not building a transport network anymore. You've got a transport network in an optic. I don't think I need to explain I don't need a transport network. Talking about capacity and the growth of data, it's pretty clear why we need this. So to conclude, there are a lot of different hardware options. There's a lot of configuration settings, and there are interoperability challenges. But I think the key thing to remember is the proposal here for a 400 gig ZR optic is to replace a transport network with a pluggable that you put directly into your IP router. So you've still got to configure it like a transport network. It isn't an Ethernet pluggable. It's a transport network. So as long as you're aware of all these challenges, it's a very good solution for getting high capacity over long distances with DWDM. And with that, I'm happy to take any questions.
Okay, thank you very much.
Thank you.